Hello, welcome. Today I'm going to be going over how to create a band structure and density of states graph using VASP and how to plot it using Sumo. We're going to be using strontium titanate for this. If you haven't installed Sumo yet, I recommend using the Anaconda browser, and all of the installation packages and all the instructions that you need are on the Sumo GitHub, so I'll include links to those in the description. Okay, here we are in this directory that I've set up with all of the input files. We're using strontium titanate, so the poscar is just set up with a cubic structure in all three directions. The k-points file is just a 6x6x6 k-points. And we're going to start out by doing a relaxation step. So we're going to be using incar relax. This incar file is exactly the same as any other relaxation. There's nothing different in this first step. So we're just going to copy this over and start the calculation. The relaxation step is done, so now we're going to get on to generating the wavecar file that we need for the final step. For this, we're going to look in incar wave, which has this one extra line on top of the normal file that you would generate a wavecar file with. This is n bands, which specifies how many bands that VASP should calculate. Normally it only calculates a couple above the band gap, but if we want a good looking band plot, we want to give it a few more. So if we want to choose a number for that, we'll look in eigenval and see where the top of the valence band is. Then we want to add about 10 more on top of that, just to make sure that we have enough bands. So in this one, I put down 30, because that seems like a good number. But that's the only difference that we need to make for this step. So now we're going to copy this over to incar and run the second step. Now that step has finished, so we're going to get on to generating the actual band structure. Now if we look in the incar bands file for this one, the two specific lines you need are L orbit equals 11, and you want to make sure that n bands is equal to whatever you had it on in the last step. The bigger difference with this step is that we're going to use a different k-points file. This one is going to be k-points line, because for the band structure, we want to calculate the bands along high symmetry paths through the crystal. So these are all of the high symmetry points specified. And then this gives you the number of k-points that are generated in between each high symmetry point. So you add every pair of points will generate a line through the structure, which will give you another chunk of your band graph. So we have this set up like this, and we just want to copy both of these over to the appropriate file. And then once we submit this, then we can get on to actually plotting the band structure. Okay, now that that calculation is finished, we can take a look at what files we have in this directory at the moment. Now the main one that we want is this vasprun.xml, which is the same as outcar, it just has slightly different format that Sumo is able to read. And we're also going to need the k-points file, so that Sumo knows the path through the crystal that we're trying to plot. So we're going to use an scp command to get this onto my computer because Sumo isn't installed on the cluster. So I'm going to start with the k-points file. And I'm also going to use the vasprun file. So now both of these files are in this folder. Now we can actually generate the band structure using Sumo. So we're going to do sumo dash band plot. And now you can just do this and it'll generate the structure. I want to make sure that the format is PNG, so I can just do that. And now it'll tell you all the positions. And if you look at what it's generated, this is the band structure it's made. So in an automatic band structure, all of the valence bands will be blue and the conduction bands will be yellow. Those are all the steps you need to know to generate a basic band structure using Sumo. Now I'm going to go over how to do a hybrid calculation of the band structure and how to plot that using Sumo. So the first thing to look at is just the in-car. This has the same two lines that you had, the N bands and L orbit from the previous one, plus 6 lines to tell it to do a hybrid calculation. And I'm including href cut equals -1 because VASP recommends it for doing band structure calculations. But the big difference with hybrid calculations is that because hybrid calculations take so long, you need to split up the k-points into multiple files, and fortunately Sumo has a built-in way to do that using the Sumo kgen hybrid density with some number. This is exactly the same thing as the second line in the normal line mode k-points file. It just tells you how many points it's splitting it up into along each line. So you see that there's 88 total k-points. That's kind of a lot. So we want to make sure to split up the points into multiple files. And I'm going to say to do about 30 per file. Now it's generated these 3 different k-points files. And we want to, in here, create 3 new directories called split-01, split-02, split-03. Then copy this folder into each one of the different subfolders that we just made. And it's fine to get these because we don't actually want to copy the folders into each other. Now if we go into each folder, we want every k-points file to be one of these. So I'm going to start with this first one. Now the structure of this is that it starts out with the normal IBZ k-points file that was generated on the previous step, and then it has a lot of zero-weighted k-points afterwards to define the paths through k-space without actually affecting the energies. So we can just paste that in there and then submit each of these. And then we'll do this for the other 2 as well. And that's how you start this step of the calculation. Once the hybrid calculation is done, now we need to transfer everything over to this computer and run Sumo. So, first of all, I'm going to create the same 3 folders that we made on the cluster. Now I'm going to navigate into the first split folder, and I'm going to copy over the VASP run and the k-points file. And then I'm going to do exactly the same thing for the other 2 split folders. Once all of those are done, I'm going to go back to the folder which contains those 3 split folders. And this is where I'm going to run the Sumo band plot. And once again, I'm going to use PNG format. It'll automatically detect those 3 split folders and use those to generate this plot. And as you can see, the scale is a little bit off. So I'm going to set a ymin -3 and ymax of 8. There we go. There's our band plot using a hybrid functional. Moving on, I'm now going to show you how to generate a DOS plot using Sumo. So I'm starting after the second step. Once again, the only thing is that you don't actually have to set end bands for that step, because VASP will automatically calculate the entire DOS for you. Now the interesting thing is that VASP actually always calculates the DOS, so you can generate a DOS plot anytime you want. The one thing that you need to be aware of is that you want to set Emin and Emax to a tighter range because it's normally calculated over such a wide range that the resolution isn't very good. And you can also set NEDOS to a higher number if you want, but make sure not to set it too high. With both of those, that's everything you actually need. So all you have to do is copy that over to the in-car and then run this last step. Now that the calculation is finished, we're going to get on to generating the DOS plot. So we're once again going to SCP the VASP run file onto my computer. Because we don't care about the path through kspace, we only need a VASP run. We don't actually need a kpoints file for this one. So we're going to do a sumo dash DOS plot, and I'm going to give it a format PNG. Now it's generated all this, and unfortunately, every time you generate one of these, it always has this spike at the minimum value, and I'm not sure exactly why that happens. But if you want to fix that, you can just set the xmin to a slightly higher value, say 3. Sorry, negative. And this should cut it out of the chart so it won't be causing an issue anymore. So now you can see your DOS plot. It has, right here is the band gap, here's various peaks. Because it was just using a PBE calculation, it's not a very precise DOS plot, so you'll want to use a hybrid calculation to get a more accurate one. To do a hybrid calculation for a DOS plot, it's once again almost exactly the same as a normal hybrid calculation. So I'm starting on step 3. If you look at the in-car for this step, all of this is exactly the same as a normal hybrid calculation, with the addition of the same EN_min and EN_max as I had before, and I still have NEDOS set to 301. Once again, these are the only, it's only a slight difference from a normal hybrid calculation. So I'm just going to start this up in exactly the same way, and as is typical with the hybrid calculation, it will take a little bit longer to run, but not nearly as long as it takes to run a hybrid band structure calculation. Once again, actually making the DOS plot is exactly the same as before. So I'm just going to SCP this onto my computer, and then create the DOS plot with sumo DOS plot. just with the same X-min to make sure that we don't see that spike. And now, this is our DOS plot. Finally, I'll go over how to create a combined band structure and density of states graph, and also how to style the graph a little bit. The nice thing is that in the third step you can combine the calculations so that you only need to do 3 steps, even with 2 different plots that you're making. Just make sure that you've set n bands in the previous step so that it's ready for this one. If you look in this in-car, we have the same L orbit and also any DOS, Emin, Emax, and n bands. So, with all 3 of those there, our in-car is ready. And we're also going to use the same k-points line file that we used to generate our band structure. The hybrid calculation is set up in exactly the same way as you would do it for the band structure, where you have to create multiple subfolders and put the k-points files into those. Just make sure that every single one has Emin and Emax set if you're going to generate the DOS plot from it. To create the combined band structure and density of states plot, you're going to need the k-points file and the VASP run file, which I've already copied over. So, if you want to create that, you're going to need to do sumo band plot as before, but this time we need a DOS term, and you want to give that a link to the VASP run. You can also give it a path to a different VASP run if you've run in a separate calculation, but because I combined them, I'm just going to use the same one. Now, I'm also going to set a ymin, just because I know there's going to be that same spike as before. And I'll put a ymax of 5 to make sure that's not too big. Sorry, I should make it format PNG so we can look at it. And that's what that looks like. So you can see the same blue and yellow colors on this side. These colors are defined in a document that's provided when you first install Sumo, but it is possible to modify them if you want your band structure plot to look a little different. So, if you want to do that, there's 2 different configuration files. First, you have the style.mpl style, which is used for coloring the band plot. The way that this works is that you have this function with a few different colors in it. This first one will be for the valence band. The second one is for the conduction band. The third one is for the valence band maximum. And the fourth one is for the conduction band minimum if you turn those on. So the way to turn that on is using this right here, where it says band edges. That allows you to put a point at where the valence band minimum and valence band maximum are. So right now I have it just set to black, so it'll have all of the band structure be black. Now, if you turn on colors for the band structure, you also need to provide a different configuration file for the density of states. This uses a different format where you define whatever element you want at the top, and then the orbitals have a specific color set. And you can have the same one or you can have different one for each orbitals. But you want to make sure that you have a color defined for every single orbital that you want to display in your density of states plot. Now, to provide these different style to the band plot, you want to use -- style with your style.mpl style and -- conf with your dos.conf. And these can be different names as long as they have .mpl style and .conf. And whatever elements that you want to display, you also need to use -- elements with all of the orbitals listed. And you see that every single one of these orbitals I have defined in here. If you don't, then if you put in an element that isn't defined in this folder, then it'll give you an error. But you don't have to have every single element in the density of states listed here. It just won't show up if you do that. But the format for these is you can have whatever element and then a dot and then the orbital. And you can also have multiple orbitals. So if I run this, this will give me a plot that looks like this. So you can see that all of these are black. They have the valence band maximum, the conduction band minimum are marked, and all of these orbitals are nicely colored over here. So I hope that this has been helpful. I know that there's a lot when you're looking into this, and it's a little bit complicated, but I'll provide a link to the documentation as well so that you can look through all of the different options that are available to you, and maybe you can figure out some other cool stuff you can do. Thank you.